You are welcome to Solo for Math, where we make mathematics simple, clear, and enjoyable. Today's video, we are going to talk about applications of what we so far looked at in trigonometry in video 1 and video 2. Basically, we are going to look at questions and answers. If you haven't watched these videos, for consistency, I advise that you go and check on them. You can check in the description, the links are attached. Okay, let's start with these questions. Number 1, simplify 1 over square root of x squared minus a squared when we given x as a cosec theta. We want to simplify this. What do we do? Of course, we just substitute. Where there is x, we put the a cosec theta. So we have 1 over square root of x squared minus a squared equaling 2. When we substitute, this will be 1 over square root of x is now a cosec theta. Remember, this is squared minus a squared minus a squared. On simplifying, you realize we can write this as 1 over square root of, this becomes a squared cosec squared theta minus a squared. If you look at what is in the square root sign under the square root, we have a squared cosec squared theta minus a squared. You see that a squared is a common factor. When we factor it out, remain with cosec squared theta minus a 1. If you remember, there is an identity that we proved, which is cot squared theta plus a 1 equaling to cosec squared theta. If we substitute this here, the cosec squared theta here, we shall end up with, this will become a squared. Now it will become cot squared theta. So this is what we are going to put under the square root here. So this is 1 over a squared cot squared theta under a square root. So the square root goes with the squares. So we remain with 1 over a divided by cot. But you know cot is the same as 1 over tan. Okay? So it means this will be the same as 1 over a times, since this is 1 over tan, if we change this to multiplication, then we get the inverse, it will be times tan theta. So our answer is 1 over a tan theta. This is how simple we can make that. Let's look at another one. We want to eliminate theta from the equations. We have x equals to a sine theta, and then we have y equals to b tan theta. We want to eliminate theta from these two equations. The first thing, the best way is to identify how these two trigonometric ratios can be related. What relates these two trigonometric ratios? If I look at them, I can identify that sine and tan are reciprocals of, for example, we know that cosec theta is the same as 1 over sine theta. Then We know that tan is a reciprocal of cot. So like cot theta is the same as 1 over tan theta. And there is an identity that relates cosec and cot theta, which is cot squared theta plus 1 equals to cosec squared theta. You can see that there is a relationship. So we want to use this. So what we have to do is to identify, we have to look for the cot squared and then the tan squared. The cot squared and then the cosec squared. So from these two here, we can first find from the equations given x equals to a sine theta. We see that we can get sine theta as x over a. So from this, what is the cosec? We know the reciprocal of sine is cosec theta. So cosec is the reciprocal of this, which is a over x. But what we want is the square of the cosec. So cosec squared theta is a squared over x squared. Do the same for this. From this, we see that our tan theta is equal to y over b. So we want to get cot so that we can substitute in our identity. So what is cot? Cot theta is equal to the reciprocal of this, which is b over y, and therefore we get cot squared theta, which is a square of this. So if we substitute in our identity here, cot squared theta plus 1 equals cosec squared theta, our cot squared was b squared over y squared plus a 1. The 1 is here. I'm just substituting directly here. This is equal to cosec squared theta, but cosec, we got it as a squared over x squared. So we've succeeded in eliminating theta. The question was eliminate theta from these equations. So we've succeeded. Maybe we just need to rearrange. I can rearrange it as a squared over x squared equaling to b squared over y squared plus 1. That is it. All right. More examples. If s is given as sine theta, simplify a. We are given s as sine theta, so we want to simplify this. If they want us to simplify 1 minus s squared, it's a matter of substitution. Let's substitute. This is the square root of 1 minus s is sine theta, but we have a square here, so it means to be sine squared theta. So if you look at what is in the bracket, under the root, there is an identity we looked at in the second video where we said cos squared theta plus sine squared theta equal to 1. So if we make cos a subject, cos squared theta a subject, you see we end up with 1 minus sine squared theta. So where there is this, we are going to put this. So it means under the root we have cos squared theta, and this is a square. We'll go with this root, we end up with cos theta. So we've simplified. This is equal to cos theta. Part B, how can we simplify this? S over square root of 1 minus s squared. We substitute simply. Our s is sine theta over what is in the denominator. You can see what is in the denominator. We already got it here. So since we've gotten it already, I will not go through the same steps. I'll just substitute. So you see that the denominator is equal to cos theta. If we had not gotten this, we would go through the same procedures to get what the denominator would be. So this is equal to sine theta over cos theta. It's more beautiful writing it as tan theta. It is more simpler to write it as that. Part C, we are simplifying 1 minus s squared over s. Let's substitute. Our s is a sine. Now, because there's a square here, this will be sine squared theta over sine theta. We go back to this identity. We already found out that 1 minus sine squared theta is the same as cos squared theta over sine theta. So we can write this in a beautiful way. If you see, I can separate this to give me cos theta times cos theta over sine theta. Cos theta times cos theta is the cos squared theta. So this one is the same as cos theta times cos theta over sine theta is cot. We already talked about this cot theta. So our beautiful expression will be cos theta cot theta. As simple as that. All right, more examples. If C, let's check for the sake of cos now. If C is cos theta, simplify. Let's simplify this. C over 1 minus C squared. Just substitute. Where there is C, we put cos theta over 1 minus cos. Since this is a C squared, so it means our cos is squared. Okay, now when you go back to the identities, the one relating sine and cos, you realize that 1 minus cos squared theta is the same as sine squared theta. You can check. You just try to make cos squared theta a subject. You see that you have this on the right hand side. So we can simplify this by considering one sine with a cos, and then times, we separate the other sine, so it will be times 1 over sine theta. And this is cos theta over sine theta is cot theta times 1 over sine theta is cosec theta. So it means this simplified would give us cot theta cosec theta. All right. Let's try this with t. If we have t defined as tan theta, we want to simplify t over square root of 1 plus t squared. Just substitute, we have this as tan theta over square root of 1 plus tan squared theta. Now, when we go back to our identities, there is an identity that relates tan and sec, and we see that 1 plus tan squared theta is equal to sec squared theta. So where we have this, we are going to put there tan, we are going to put there sec squared theta. So our expression, this one becomes tan theta over square root of sec squared theta. And this is, when we simplify, the square goes with the square root, So remain with sec theta. We can simplify it, write it in a more simplified way. So we see that tan can be written in terms of sine and cos. So this is sine theta over cos theta times. Remember, this was initially division, like we were dividing by. Okay, let me not skip. We were dividing by sine theta cos theta divided by sec theta, but sec theta is same as 1 over cos theta. So when we simplify this to be sine theta over cos theta times, if we multiply, the cos goes up, cos theta over 1. So you see this cos goes with this. So we remain with a sine theta. So it means this simplified is equal to sine theta. More examples. If x is given as a sine theta, simplify 1 over square root of a squared minus sine minus x squared. We simply do substitute. Where there is x, we put the a sine squared theta. So we have a square root of a squared minus, where there is x, we put the a. Remember, this is x squared, so a will be squared, and the sine will be also squared. All this is under a root. So this is equal to 1 over square root. If you look at what is in the bracket here, there is a common factor, which is a squared. When we put it out, we remain with 1 minus sine squared theta, which is equal to 1 over square root of a squared. What is this? There is an identity relating cos and theta, and cos and sine. So 1 minus sine squared theta is the same as cos squared theta. So when we simplify, this is 1 over a, like the root goes with the square, the two squares actually. So we remain with a cos theta. Simplifying it, writing it in a beautiful way to be 1 over a times 1 over cos theta, which is 1 over a times 1 over cos theta. We know it as sec theta. So it means this is 1 over a sec theta. Simplified. All right. More examples. We are still looking at applications of whatever we learned in the 2 videos about trigonometry before we may move on. We have this other kind of application. If we are given sine theta as 3 over 5, we want to find, and we are required to find, the cos of theta and the tangent of theta without using a calculator or tables. Okay, this is mathematics. Beautiful. Let's move on. How do we handle this? The first thing is we identify what is given. We are given sine theta as 3 over 5. If I refer to a right-angled triangle, and this is my angle theta, it means they have given me from soccer tower the opposite. This is the opposite, and they have given me the hypotenuse. So the opposite is 3. They have given me the hypotenuse as 5. So to get the cos theta, which I know can be got from adjacent over hypotenuse. It means I need to find the adjacent. Just like for the tan, which is the opposite over adjacent. So you see, the two of these require the adjacent. So since this is a right angled triangle, we're going to use Pythagoras theorem and find the value of x. So from Pythagoras theorem, we know x squared plus 3 squared is equal to 5 squared. So it means my x squared will be equal to 5 squared minus 3 squared. So my x will be equal to square root of 5 squared, which is 25, minus 9, 3 squared. So square root of 16, and this gives me a 4. So it means my x is 4, therefore my adjacent is 4. So it's now a matter of substitution. Part A, we want cos theta. So cos theta is equal to adjacent over hypotenuse. So the adjacent, we have it as 4 over the hypotenuse as 5. Okay. Now we would ask ourselves, is cos theta positive or negative? Because they didn't define for us. In this question, theta was not defined as acute, obtuse, or a reflex angle. So if theta is acute, we go back to our quadrants. Remember we said in the first quadrant all the ratios are positive, in the second sine is positive, this one all, in the third only tan is positive, in the fourth only cos is positive. So looking at what was given, sine theta was positive. So we expect sine theta to be positive either in the first or the second quadrant. Okay? But the location of sine of theta determines the sign on cos and tan. Because if it is located in the first quadrant, here we know that cos will be positive and tan will be positive because all ratios are positive. But if it is found in the second quadrant, if theta was obtuse, then it means sine is positive, yes, but the cos and tan will be negative. So we expect two solutions here. So this is when, if theta is acute, between 0 and 90. And then what if theta is obtuse, between 90 and 180? It means our cos theta will be the same magnitude, but the sign will change, because in the second quadrant, where we have obtuse angles, cos is negative. Let us look at tan. Tan theta would be equal to opposite, which is a 3, over the adjacent, which is a 4. This is so if our theta is acute. If theta is acute. Because here we have all the ratios as positive. If theta is obtuse, then our tan theta will be equal to a negative 3 over 4. Yes, because in the second quadrant where we have obtuse angles, tan and cos are negative. But still, we have sine positive. So we said, like we said, sine could have, theta could have been in the second quadrant or in the first quadrant. So since they didn't define, we expected two sets of values of sine, of cos theta and then tan theta. Let's look at one more example. If cos theta is equal to negative 8 over 17. And theta, here we are defining the theta as obtuse. If cos theta is negative 8 over 17 and theta is obtuse, we want to find A, the sine theta, and B, we have to find the cot of theta. Okay, let's proceed. The first thing is identify what is given. If I draw my right angle triangle as this, and my theta is here, this is right angled. What is given? From cos, we know we have the adjacent and then the hypotenuse. So if this is the hypotenuse, it means we have 17 given. We have the adjacent. If this is theta, the adjacent is here, negative. The negative here is representing the quadrant in which that angle is formed. So here we're picking the positive values. All right, so the next thing we do, of course, is to find the adjacent if we don't know it. Like here, we don't know it, so it means that y squared plus 8 squared using the Pythagoras theorem, 17 squared. So it means my y will be equal to square root of 17 squared minus 8 squared. What do we end up with? This will be a square root of 225, which is equal to 15. So it means my y, which is my opposite in this case, is 15. Okay, so we want to find sine theta, which we know that sine theta is equal to opposite over hypotenuse. So what is the opposite here? The opposite is 15 and the hypotenuse is 17. Now we are remaining with the sine. Which sine do we have for the sine theta? In this case where theta was obtuse. If theta is obtuse, then it means the angle, our angle was falling in this quadrant, second quadrant, where we have only sine as positive. You can careless even here. Cos is negative, sine is positive. So it means this answer is a positive answer. So sine is equal to 15 over 17. What about cot? Cot, that is part B, cot theta. This one can be defined or got by relating it with tan theta. So if we find tan theta, we are able to get the cot theta. So let's start with tan theta. Tan theta, which is the opposite over adjacent. All right, what is our opposite? The opposite is y, which we got as 15, over the adjacent, which is 8. So what is sine? What is the sine of tan theta in the second quadrant where our theta is? Because they told us theta is obtuse. So if theta is obtuse, it lies under here, the second quadrant, between 90 and 180. Here we have on a sine as positive, so it means our tan is negative. So if we have this as our tan, we know cot is the reciprocal of tan. So what is the reciprocal of this tan? It will be 8 over negative over 15. This is it for today's video. Please, you can try more and more of these questions. If you've liked this video, don't forget to like, to comment, and to share to anyone who may need this content. Please don't forget to subscribe.